Right, everybody, now I'm going to talk about power. So you can see from here, power is the amount of work or energy done over a period of time. So power actually has a very simple equation. It's just the work or energy divided by how much time, and we usually deal time with seconds. So an easy way to do this is with an example. And also before that, I want to tell you what power is measured in. Power is measured in watts or kilowatts, and 1 watt is just equal to 1 joule per second. So let's say we have 50 joules for 1 second. That means we have 50 watts. If you look at a microwave, it tells you the amount of watts. That actually just tells you how much joules it releases per second. So a kilowatt, if you remember, a kilojoule is 1,000 joules. A kilowatt is just 1,000 watts, which is just the same as 1,000 joules per second. Or you can just convert it from 1 kilowatt to 1 kilojoule per second. All right. So let's just do a simple example. Let's say a microwave oven does 5,000 joules of work in 5 seconds. What is its power? Okay, so let's do this. So power, which we have as a P, equals W divided by T. W is the work, T is the time. So if we do 5,000 joules, it said, and then in 5 seconds, all I have to do is plug it into the equation. P equals 5,000 divided by 5, which is pretty simple. That's 1,000 joules per second, or 1,000 watts. That's it. It's pretty simple. And now we have another example. This is a little bit backwards. So a 1,500 watt microwave was on for 30 seconds. What was the total energy that the microwave emitted? So this time I give you the power and the time, but you need to find the energy. So we're working backwards. So for number 2, again, P equals W divided by T. So if P is 1,500, I believe. Yep. And T is 30 seconds. And we need to find W. All right, so let's just plug this in. So we have 1,500 equals W divided by T. Or why did I do divided by T? Divided by 30. So we have to do here, just multiply by 30 to both sides. Okay. So to do that, 1,500 times 3 times 30. Well, 15 times 3 is 45, so we know we have to put that. And then there's 3 zeros, so we're gonna have 45,000 joules. That's the answer. Okay, pretty simple. Another thing, let's say we have this time T was 5 and W was 100 kilojoules. The power will be a little bit different. So we have 100 kilojoules divided by 5 seconds. That equals 100 divided by 5 is 20, so 20 kilojoules per second, or we could just do kilowatts. All right, the last thing I want to do is this time an example with minutes. So let's say something has, let's see, we're trying to find power again. And this time we know it goes for 600 kilojoules. But this time the time is 1 minute. So you can't just do 600 divided by 1. You have to change minutes to seconds. So if time is 1 minute, that means it also equals 60 seconds. So when we calculate power, it'll be 600 divided by 60, not 1, because we have to put seconds. So we do that. That's just 10 kilojoules per second, or 10 kilowatts. Okay, that's it for power. Now there's practice problems for you to do. These practice problems involve calculating efficiency and power in just some simple word problems. Right now, we're going to focus on the calculations. Next lesson, we're going to talk about incorporating power and efficiency for actual power plants. So, oops. You'll have this lesson 9 practice, and it'll have basic word problems to solve for efficiency and power. And I believe there's 5 questions total. It won't be this zoomed in when you click on it. Right, there's 6 problems. Right. Right, so that's everything about power and efficiency. Let me know if you have any questions. I'll be happy to help you. Bye.